Hi, and welcome to Fusion 360. Today, we're going to be talking about Fusion 360 electronic design capabilities. We'll be live in a few minutes. Um, yes, I just need to fix my audio. I hope everybody's doing well. As as more people join the room, we always like to ask, where are you located? I guess to let you know, Jorge and myself are located in South Florida. He's located in Miami. I'm just a tad further north. I'm in Fort Lauderdale. We would love to learn to more like where are our friends coming from. So if you don't mind, use the chat. Jorge will be manning the chat today. So let us know where you dialing in from. Oh, hi Hanson. Thanks for being here. Greatly appreciate it. Hola Fabricio. Thank you for being here as well. So we have some friends from Italy. Thank you, Richard. Greatly appreciated that you're here with us. I'll be turning off my camera shortly. That way, I will not be a part. It will not be part of the distraction on your screen. But I always like that way you have an idea what Jorge or myself we look like. So I like having the camera on for a little bit. So Hansen, oh, from Germany. I think we've spoken with Hansen in the past for some reason. I feel that we've done some emails or something like that with him, and we have some. Oh, okay, we have a lot more friends from Germany as well. Thank you and welcome. Anybody else? Okay, we'll be starting in just 1 minute. From Hi Pat, thank you for joining us from Liverpool. Greatly appreciate it. Our friends from Italy in the house. Well, today we're going to be talking about the future electromechanical designs using Fusion 360. But before we do that, I'd like to just go through some slides to give you an overview of what we're going to be talking about today. So let me just go ahead and stop my camera. Jorge will be taking care of the chat. So throughout the conversation or throughout the presentation, please place any comments or any questions that you have on the chat, and Jorge will address it. If it's necessary, Jorge will let me know, and I will just go ahead and review that on the screen as well. So everybody seems to be seeing my screen, so we're good to go. Oh, Suraj from Japan. Hey, thank you for joining us. Wow, that's a big time zone difference. So I hope you're doing well. Okay, so just to let you know who you're talking with, my name is Edwin Robledo. I've been part of the support team for Eagle back in the early 90s and transitioned over to Autodesk for the last 4 years, working with Eagle as well as Fusion 360. I have the opportunity to work with many of you through live streams, through blogs, or through support cases. And we also generate some content for our marketing teams. And Jorge has been with us maybe for the last like 12 or more years. Jorge has been with us. You'll see his presence heavily on the forums. Takes care of a lot of the forums, and if when you schedule a call, it's quite possible, and it has to do with electronics. It's quite possible you're going to be talking with Jorge. Now, let's talk a little bit about what we're looking for here. So, when you're designing a brand new project or a brand new product, there's three key ingredients that you're going to be needing. You need collaboration. You need a system that gives you smart design capabilities and being able to work in a unified platform that really streamlines a process to easily make changes and analysis. Could you imagine one single application that could do all this and do it well? So let's take a look at what we have. As you already know, Fusion 360 is a cloud-based product development platform that combines industrial design, mechanical engineering, machine tool programming, simulation, and electronics all in one software. Traditionally, you would need around maybe between 3 and 5 different applications to be able to have all this under one roof. With Fusion 360, you get all these capabilities under one roof. Gone are the days of having to use multiple applications. A true unification in the design process of smart products has been accomplished with Fusion 360. Fusion 360 Electronic has all of the capabilities and resources to design a schematic, circuit board, and for complex designs. Not only file conversions is no longer needed, but you'll be working in a familiar interface. Switching from electronic tabs to mechanical design is only one tab away. I have a little bit of a success story which has been shared with us. There's a company called Life Fuels, which have adopted the platform of Fusion 360 for their future designs. They make a smart water bottle in which actually it squirts vitamins into the water, and it kind of keeps track and tabs of your of how much you've been taking of the water. So one of their main engineers had the gave us this quote that Fusion 360 has allowed them that to allow mechanical and electronic engineers to work in a collaborative way to fit everything in one small space in the bottle. So in other words, traditionally you would have to be using IGES and step files, be able to convert between electronic engineers and mechanical engineers just to make sure that everything fits. Having two different applications, they're only having one application, so it has really streamlined their design process. Now, let's talk a little bit about the Fusion 360 electronics design capabilities. First of all, we have what's called a schematic editor. Our schematic editor does include a spice simulation capability, and the nice thing is that it's 100% annotation between the board layout. In other words, modifications done to the schematic actually affect the board in real time. Now, the circuit board is where you're going to be working with the physical aspects of your circuit board. This is where you're going to be using real dimensions of the board, and what you see is what you get. Here you're going to be doing your routing, which we have a host of manual and manual interactive routing, as well as an auto router. And if there's some changes that could be done to the board layout, those will actually take effect into the schematic. So if you name a component or you rename a signal in the board layout, it will actually in real time back annotate that information back to the schematic. Then we have a library editor. We have a really extensive amount of libraries available in Fusion 360, but we don't have them all. But we're doing our best, and we've given manufacturers and some distributors access to our repository. That way they could have control of their own components. Now, we do include a library editor in which building your own component is pretty streamlined and pretty straightforward. And I'll be reviewing that shortly as well. Last but not least, what links all of the electromechanical designs between the mechanical workspace and the PCB is called our 3D PCB. That's where any change is done, that's where it's going to take. And I'm going to be reviewing exactly how this workflow looks like now. Now, we have our design workspace, which is our mechanical side. We have our PCB design space, which is what you see here on the right-hand side. And in between them, we have our 3D PCB. Now remember, this PCB is not a render. This is not a canvas. These are actually extruded bodies. Every trace, every via, every component here is actually an extruded bodies, which can have materials assigned to them. So if you're going to do any type of e-cooling simulation, it will actually get you the readings as close as possible to reality. Now let's talk a little bit about the workflows here. First of all, between the circuit board, the PCB, and the 3D PCB, there's 100% back and forth annotation. So changes done to the PCB will affect the 3D. Now, there's some modifications that could be done in the 3D PCB. For example, like board outline changes or moving components could be done in a 3D PCB. Well, you know what? That will affect the circuit board as well. So you have a back and forth annotation. Now, between the design workspace and the 3D PCB, there's also a really nice workflow as well. Notice that by placing the circuit board inside the 3D PCB, inside the design workspace, I could use what's called edit in place. That way I'm able to, that way I'm able to, that way I'm able to make any, so I could insert the 3D PCB into my design workspace. And we have the capability, if you've been using or looking at Fusion at all, we have something called edit in place. I could actually make changes to component placement on the design workspace, and that actually annotates back to the PCB, to the 3D PCB, which in turn will go back all the way to the circuit board. So as you could see, all the latest changes are always adopted by the 3D PCB. It's really important that you understand this workflow. So the 3D PCB is always going to have the latest version. So in conclusion, what am I trying to say? You never could go from the design workspace directly to the PCB. It has to go through the 3D PCB no matter what. And why is this important? Because we want the 3D PCB to always have the latest version of the design, the positioning of all the components. Why? Because I could actually set up thermal loss in terms of watts to my 3D PCB. And guess what? I could do some e-cooling analysis, all in Fusion 360. Let's say I want to have a really nice render because I'm going to use it for marketing, or I want to show the progress that I've done with my PCB to either executives in your team or maybe anybody that is supervising the project. Well, guess what? You could give them some really nice renders of your project. But not only that, let's go into manufacturing. As you know, Fusion 360 can drive CNC machines. Therefore, you could actually configure it. That way it could drive the CNC machine and etch out your circuit board on a copper clad. All this within Fusion 360. We're always on the same application. Let's take it a further more. We could actually create the manufacturing drawing from within Fusion 360 by using the drawing capabilities of the Fusion 360 has included. And last but not least, and we already had mentioned, is we can actually insert our PCB inside the enclosure, or we could insert the PCB into a design workspace and create an enclosure around that, depending on what workflow you wish to use. In our example, we're actually going to have an enclosure which has already been created by a mechanical engineer, and we're going to be capturing that geometry and inserting it into our circuit board is the workflow that we'll be demonstrating today. So let's go ahead and let's go live with Fusion 360. So you just give me 1 minute. That way I could switch screens real quick. I made the mistake of opening up another session of Fusion 360, so I'll go ahead and ignore that. Hopefully it will not come and bother us. Well, if you've used Fusion 360, or this is the first time you use it, when you open it up, this is more or less what it looks like. This is what we call the design workspace. Design workspace is where you're going to be creating sketches and where you could use enclosure or anything that you want to 3D print. It has a really the capabilities in the design workspace. You could actually 3D print as well, which I've done quite often. Now, let's say how is that we're going to access the design workspace, the electronic design workspace. As I mentioned earlier, I told you about libraries, creating your own components. Creating your own components could be quite a tedious process. So how do we create electronic components that we're going to be using in our schematic and our circuit board? So let's go ahead and you click on the file pull-down menu, and you see where here it says new electronic library. This will bring up the electronic editor. As you could see, the workspace is very similar to the regular design workspace by default. They're almost similar. You'll notice that we have up on top the different tabs and it changes sections. Well, in the library editor, we have the same thing. You'll see that we have the different tabs on top and it changes the editor as well. Okay. On the content manager, we have our devices, we have our schematic symbols, and we have our footprints. If you have never used the library editor in Eagle or in Fusion 360, you'll know, just to let you know, that devices is basically the union of a schematic symbol and a footprint. When you put them together, you create a device. Now, one of the nice features of actually using the library editor in Fusion 360 is when you're going to create footprints. Building footprints might be the most tedious process of creating components in any application. Well, with Fusion 360, they made that really easy. We have something called a package generator. Package generator is invoked right here. It's called create brand new package. The package generator includes an IPC compliant component generator, as you see right here. I could select a template that already exists. In this case, I'm just going to go ahead and select a SOIC. From the specification sheets from the manufacturer, you're going to get all the mechanical details of the construction of this component. You're going to find those values right here in the fields that we have, respected fields, depending on the legend. Once you actually have submitted all of the values that you need, you click on Preview Update. Now here you're going to be able to see the 3D, it will build the 3D model. Notice that it's actually building the component. It's using different shapes and extrusions and creating the different planes and whatever is necessary to actually build a component. It's not creating a canvas. It's not an illusion. It's actually creating the component in its entirety. Notice that the 3D model is built and shortly is built. And so let's go here. Okay, I'll move in a little bit. Now, the hatched lines that you see here, these hatched lines are indicating what's going to show up on the circuit board. This is what is going to show up on the PCB. These are your soldering leads. This is how it's going to solder. And the rest, based on these dimensions that you get here, it'll build a 3D model. Now, as you notice, there's two columns for minimum and for maximum values. So let's say, for example, you plan to manually solder these components. It's quite possible that you may want to go with the most, with a larger value. Well, at least I have to, because my manual soldering capabilities are not the strongest. Therefore, I'll always use the pad, the largest possible value I can. Now, if you're using pick and place or you're using a wave solder oven, it's might possible that you may want to be able to go with the least. You know, you want as much space as possible on the board. You want the board to be as small as possible. So I may use the minimum. And I do that, I'll click here and update, and you notice that in a few seconds, it actually changes. If I'm satisfied with the component that I've created, I'll go ahead and click on Finish. It'll ask me if I finished creating a component and you want me to add it to the library. I'm going to go ahead and say yes. In a few seconds, it'll build it. Okay. And here it's created the package. Now let's take a look at the footprint that it created for us. Here's the footprint. And here's the footprint is completed. You know, creating the footprint usually means that you got to figure out a grid that is going to give you the appropriate spacing, the pad size as well. All this was taken care of by just plugging in the values from the manufacturer and building the component for me. So this is one of the main advantages that we have, and it truly aligns with electromechanical capabilities available using Fusion 360. Now, let's go ahead and start building our first schematic. Let's access the schematic editor, or let's access what we call the electronic document. Remember that on the PowerPoint, I told you that Fusion 360 keeps annotation between the circuit board and the schematic editor. Now, to be able to accomplish this, we need to create an electronic document. For those of you that have been using Eagle, you'll remember that you could actually place the schematic on the board. As long as they have the same name and the same folder, Eagle will keep track of them. with Fusion 360 being cloud-based, we actually have created something called the electronic document, which has a lot of advantages of it, because now I'm able to associate one schematic with different circuit boards if necessary. It's kind of neat. So it actually expands these capabilities. But I'm going to keep it simple today. Let's go ahead and create our first design, our first electronic document. So I'm going to click on the File pull-down menu, and I'm going to go here where it says New Electronic Design. This will bring me into the electronic document. For those of you that are Eagle users, the way you would handle this, if you want to upload your Eagle designs, because Fusion 360 is 100% compatible with Fusion 360, what you would do is you would click here where it has that link. I would click there, and I would say I want to bring it from my computer. I would select from my computer, and then I would navigate my computer and find the files that I wish to upload. Then once I do the schematic, I'll do the same for the circuit board as well. And I'll do this in the electronic document. Once I do it in the electronic document, that means that they're now associated and they will keep track of it as well. Now, let's go ahead and work on a design that I currently already have. So let's go ahead and take a look at that document that I already have open. So I'll close this one. And this is what the electronic document looks like right now. This is the one I'm currently working on right now. You notice that you could see the schematic. The nice thing of the electronic document is I could preview my schematic per sheets, as you could see here. I could preview my circuit board as well, okay? And in this case, I actually already have, no, I do not have a board yet with this as of yet. Let me say what I've accomplished so far. So this is what the electronic document looks like, and it'll keep track of my circuit board as well as my PCB. That way I make sure that I have annotation. Now let's open up the schematic. This is a schematic editor. You'll notice that on the bottom of the screen, we have the different sheets. Fusion 360 is able to handle up to 900 sheets per design, which I've never really worked with more than like 30 sheets. But you're able to navigate throughout your sheets, as you see. The same as you saw in the Fusion 360 interface, you have the different tabs, and the tabs will actually switch depending on which environment you're working on. The very first tab, usually the very first toolbar, which is switching between board and schematic, will remain there as always. Now, let's talk a little bit about these screens that you see on the outer layers here. These are panels. These are very good information panels, very useful information panels, what I want to see. I could categorize it by parts. I could categorize it by groups if I have groups defined, or by signals or by nets. So if I need to find a part, you could actually type in the parts here if necessary, and maybe most probably just find the part. So I just type R1. So it's actually letting me know where R15, R11, and R16 are located. But you could also create filters. So if you want to create a filter to find a particular part with a particular name, and then you could just, so let's say I want by name, and I want everything that starts with the letter R, put an asterisk there, and I'll click apply, and you find them there as you see it there. Now, as I select components, notice that then on the inspector, I actually get all the details of that component. It's like looking at the properties of the component directly without having to open up a property window. So as I select components, you'll notice that I see here the properties of that component. If I select a group of components, I left click and drag, you'll see that every property, the components, the traces, all the text, I see those properties on the inspector as well. If I wish to filter what I'm actually going to select, I could click here where it says on the selection filter, and I could select the option, 1 second, module, polygon, dimension, frame, junctions, labels. I practiced this earlier, attributes. Oh, part, okay. If I only want to select the parts when I'm defining my group, I could select here in parts. When I select this group, you'll notice that it's only going to now filter and show me the resistors, the diodes, and the supply pins for our 3 volts, 12 volts, and 5 volts, as well as our grounds that's showing up. So it ignores anything that is not a part. So it's actually pretty useful. Now, let me switch over this to sheet number 3. So that kind of takes care of the panels, and which are extremely useful. I use them all the time. I use them quite often. So I'm going to add a component to our design, and I'm just going to click here on the add dialog box. It wants me to save, so let's go ahead and save it. Okay. Once you click on the add command, you'll see that we have hundreds of libraries or repository libraries. All these Worth libraries, these were not added by us. This is actually Worth Electronics has a repository that we have assigned to them, and they manage their own components. And they have access, so our users have access to the components created by Worth. Now, if I want to access more of the available libraries, you click here where it says Open Library Manager. Not sure why that keeps on coming up. It wants me to save. Once I open up the library manager, it's going to show me all of the components that are being used in this design. These are all the components that are currently in use. These are all the libraries that I currently have in use. And in this tab here where it says available, these are all of the components that are available either by hubs that I'm sharing with customers or sharing with Jorge or our team or librarians internally or externally. Now, notice that we have many more libraries available. Right here, this little symbol that you see here means that I could actually select it, and I select use, it will actually download that library. So we have so many more libraries available, maybe a little few thousand of them. This symbol that you see right here is a symbol letting you know that this library has been updated. In other words, I was using this library and the original author has made changes to the library, and there's updates to it in which I could actually select it. And you'll notice here on the bottom right-hand corner, it says update. So I could update to the latest version of that library by selecting here, update. Okay, so we have from Adafruit, from SparkFun, Seed Studios, TE, Tyco Electronics, many more companies that are contributing to our repository library. PCBlayout.com will also have access to our repository and are adding components consistently. So that's how you access other libraries that are available. Of course, if you are a Eagle user and you've created any managed libraries, those will show up on that list as well. So if you've already been using Eagle and you have managed libraries that you've created, as long as you're using the same credentials that you logged on to Eagle, if you use those same credentials to log into Fusion 360, you will automatically have access to those libraries that you've already been working with, okay? I'll click here and click on cancel. Now I'm just going to add a component that I need here. So let's go ahead and click on this component here. Let me just go and find the part that I need here. It's just an SD connector. So I'll just click here and select it. And I'm just going to go ahead and place that SD card there. It automatically puts another component on the mouse cursor. I don't need one. So if you're adding resistors or capacitors or inductors, you may need to have several of them. In this case, I only need one, so I'm going to hit escape. But if I needed many of them, you could just keep on left clicking to place more of them. So I'm going to hit escape. Now I'm going to invoke the shields for this SD card reader. I'm going to click here and select the SD card reader. And then I'm going to just make a duplicate of the ground pins. I'll just create a duplicate right here, and I'll just, just place that there. Just put our ground pin show. Now, when it comes to schematics, it's quite possible that you want to create or document or organize your schematic in groups depending of the functionality that they have. So let me show you one way that we have groups here. We call it persistent groups. So I'm going to create a group. I'm going to select all these components. I'm going to go here and do a right click. I'm going to select the option a new group, and I'll call it the reader. And I'll click OK. And now I have my group. Now, if I need to move this module throughout my schematic, I could just select the component. Give me one moment. Oh, I have to reset. Okay. So here we go. So now I'm able to move that group depending of its functionality. So I could keep them neatly organized. I could keep on doing more groups depending of their functionality. Usually it's done by functionality. So as you see, I create the group, I right click, I select new group, call it Ethernet. Okay, so there's my group, and I could keep on categorizing each one of them. Now let's switch over from the schematic, let's switch over to the circuit board, and that's easily done. You'll notice that on the schematic editor up on top, I have this icon here that says switch to PCB. I'll go ahead and switch to my PCB. And because of my back and forth annotation capabilities, you'll notice that the component automatically showed up on the bottom left corner of our design. So I'm just going to left click and select that component. I'm going to right click to rotate it. Okay, now you start adding that component right here where it belongs. I'm having some trouble adding it right there. I find the right spot. Now, the reason you see it jumping like that is because I have the environment called push violators. In other words, if there's anything that is going to jeopardize the manufacturing of this board, it's going to do its best to avoid it. So let's say if I use overlapping copper, in this case, I have a component, I'm putting it on top of some traces, it's going to jump around. So let's go ahead and change our grid. Let's switch to a grid. We have a 5 mil grid. I'm going to select the component. I'm going to start moving it a little closer here. I want you to see what happens. As I move it around, it's kind of seeing some violations. You notice that it jumps the board outline. It actually jumps that way. It keeps at least an 8 mil distance from it. It kind of jumps around, doesn't really let me have control of it because it's making sure that I'm not violating DRC at any point in time. Now, I could change that environment, and I could change it that way it ignores violations. So I'll click here where it says ignore violations, and I'll go ahead and move that same component. That way you could notice the behavior difference. Okay, so let's go ahead and grab the component right here. And as you can see, it's moving now freely because I've told it to ignore. But what happens when I use this environment? Let me get a little closer. That way you can see what's going on. Notice that as I move the part, you see some hatch markings show up. You see these hatch marks that show up? These are just live DRC. It's letting me know that I have violations going on. So it's just lets me do the violation, but I do have some DRC letting me know that there is a violation. So let me just go ahead and put this back where I would like it to have it right there. Okay, now let's talk about one of the really cool features that we have, which is an environment setting, which we refer to as, it's down here in the panel, right-hand corner, and I'm going to select the option what's called push violators. I'm going to select an unrouted component, a component that you place. I'm going to select this resistor, and I'm going to move it, and look how it works. I'm going to click on the move command. This is an unrouted part, right? First of all, look what happens when, okay. I'm going to start moving it. As you could see, this is what we call our version of push and shove environment. You'll notice that it's actually moving the traces out of the way, not moving them out of the way, but it's kind of like pushing them. That way I can make space for this resistor that I actually want to add. Okay, and it's taking into consideration the manufacturing settings from DRC. Okay, as you see, I'm going to hit the middle mouse button just to put this resistor on the bottom side. As you can see, it's in blue. And let's see how it reacts on the bottom layer. As you see, it reacts exactly the same way. Now, this system will not move components. It will move vias, it will move traces, but it will not move components, okay? That's the idea behind that. So I'll hit escape, that way you see it. Now, we have a host of routing capabilities. We have our manual route, which is the one that you're most commonly used to. We could route differential pairs. When we select differential pairs, you'll notice that all the differential pairs will highlight. You see we have a bus right going on right here. So we could actually just select this one and route it right here. I hit the enter, that way Quick Route will finish the route for me. So that was differential pair routing, and I could continue routing some more there. In addition to these routing capabilities here, which are kind of manual, I could do differential pair. I could do multiple lines simultaneously. I could do meandering for length matching. Then we also have a host of quick route. All right, I'll just use this one, quick route airwire. That way you could see how that works right there, as you could see. So if you have straight line connections, it will actually route those as well. Now, if you have multiple lines that you wish to route, and then you could select here where it says a manual route and select many traces if necessary. Okay. Or if you want actually to give it some sort of a guidance, I'll rip this up really quick. That way I could demonstrate this one really quick. Okay, so I'll select here, guided. I'll select these traces that I have here. I'll right click and notice how the group of signals now follow me. So this is what we call quick route guided. And now I'm going to kind of try to influence the path the tracers are going to actually be following. I'll just select here. Now to invoke it, I've given it a kind of predetermined the path. Now remember, it's not going to violate DRC, so it's going to do its best. And when I press enter, as you see, it actually does a route. I'll do it again with these on this side. And it routed these as well. Yes, kind of influenced by the path that I get given. Now, this is kind of cool. Like if you have components that are in the way and you have a group of traces that's a straight shot, and you, instead of actually breaking throughout other components, you wanted to follow a path through an outline of a board. That way it avoids any other components. This is actually a really cool tool to be able to use. Of course, remember, it has what's called active layer. I actually using the top layer, but I could have told it to use internal layers if necessary, or maybe all the layers if necessary. I could select the trace width for those traces, as well as I could set up the clearance that I want in between each one of these lines. So Quick Route is extremely useful for multiple lines. So that should really optimize your design time. Now that I've shown off some of these tools, how do we capture an outline of an enclosure and actually put it in here? Commonly, you may be used to using tools such as DXF files and import them. But here, I'm going to show you one method that we actually have. I have an enclosure here that was provided to us by a mechanical engineer. And so let me just open that up because I want to show you where I'm going to put it in. Now, this is where the circuit board is going to rest, the final product of this. This actually has like 7 circuit boards, but I'm just using this one as our example. This is a slot. You'll notice that it has a face there. Now, under the Create menu, I have a couple options, which is one is Create 3D PCB, and the other one is Create Derive PCB from Sketch. I'm going to use a Create PCB for now, okay? Now, the nice thing of the Create 3D PCB is I could select a face, or if you have sketch profiles, because you maybe drawn a sketch, I could actually use Create PCB and select sketch profiles instead. So if you have a complex board outline that you wish to use, or you want to project an existing enclosure, you could create a profile for it in using sketch profile. The projection of enclosure or projection of surfaces to create that sketch. Then I could select that sketch and actually now use it. Now let's see what happens. Be careful here. I'll go slow. Once I select my sketch profile or my face, I'm going to go ahead and create what's called, I'm going to select OK. This will create the 3D PCB. Remember, we were talking about the 3D PCB kind of being the middle person between the circuit board as well as the design workspace. So now what I want to do is I now have captured my board outline. Now I need to associate this with my circuit board. Now, since I already have an existing circuit board and I wish to adopt this as my outline, I'm going to select here where it says link to 2D PCB. I have my circuit board in the same folder. It's right there, and I'm going to select it. And notice that in a matter of seconds, now I have adopted that board outline, which I projected from an enclosure, and now it's part of my PCB. Yeah, it was that easy. Okay, no more file conversions. That's something from the past. You're no longer going to work with file conversions. Now, what I want to do is I actually want to take a look at my circuit board and in a 3D. Let's see how does this look in 3D. So now I'm going to save what I've accomplished so far. You don't have to, but I like saving. And I'm going to push this over to my 3D PCB. Apparently, I've opened up some old files or something like that. I'm getting these errors, these logs that keep on appearing on the screen. So I'm going to shoot to my 3D PCB. Now, the nice thing, as I had shown you earlier, it's currently building the circuit board based on the components that I have on my circuit board and the enclosure that I captured. Depending on the complexity of the board, this just may take a few seconds, take a couple moments just to be able to finish it. So it's synchronizing my circuit board and my 3D. Jorge, any questions or anything I should be covering while this is building?
So far, nothing, and I've been keeping track of the YouTube chat, and everything is good up until now.
Excellent. Thank you, Jorge. Appreciate that. Well, while it builds this, depending, if your design is a little smaller and depending of your internet connection, it could go as fast or as slow. I have a feeling this might be going a little slow since I'm streaming. Fusion 360 is streaming as well as I'm streaming to YouTube. So it may just take a little bit longer than what I expected compared to other demos that we use. So it's building it. Now, remember, when this process is completed, we are not getting a canvas. If you're an Eagle user and you're using Fusion 360, you're getting a canvas between Fusion and Eagle. That's what you're getting. So you can move the components in Fusion 360 if you use Eagle, but the traces and any other properties such as vias and pads, those are canvas. Therefore, you can't really do much more than moving parts. If you adopt Fusion 360 as your method of generating your PCB, then now you're getting true bodies, you're getting extrusions for your boards and your schematics and so forth. Also, some of the other advantages, which I want to demonstrate right after this, is that everything in Fusion 360 is version. It's just the nature of its ecosystem. So, okay, so here we go. Okay, so as you could see, it actually brought in the board. If I get a little closer, you'll notice that every hole, every pad, every trace, it will highlight as a particular body, as you could see. Okay, so this is not a canvas. This is not a picture. It's not to make it look nice. In addition to that, I've noticed that my reset switch has landed on top of the slot where one of the cards is going to go. I am actually able to move it. I could select it here. I can move the component out of the way. I could select the option to update the PCB and actually update the routing as well. And I'll click OK. What this is going to do is that it's going to go back to the circuit board, move the component, use the reroute command, and come back and update my 3D PCB all in the same command as we see. So this will just take a couple of seconds to update. Just remember, it's taking a little bit longer because since I'm streaming, it's just taking it a little bit longer. So in the meantime, it's kind of remapping everything, including any changes that I've done. As you see, the reset button actually has been modified, and you'll notice that the routing actually changed as well. If we go over to the circuit board, you'll notice that actually that reset button actually changed here as well, as you see here. Okay, so last but not least, I just wanted to show you that I'm able to, let me save what I've accomplished so far. That way I get the latest version. Notice that everything in Fusion 360 is being versioned. Therefore, all of my changes on my schematic and my circuit board are actually being versioned. If you notice here, it says version 14. Okay, it's refreshing everything. So if I needed to promote a previous version because the changes that I did were not the ones that I required to do, I could actually go to an earlier version and promote a version if necessary, as you see here. So you get the option to promote a version. Um, and I could do the same thing for the 3D PCB as well as for the schematic as well. Now, if you need to share this project with your colleagues, here where it says people, the only requirement is that those that you wish to share with, they need to have a Autodesk account. An Autodesk account just basically requires an email address and a password. That's all it is. So you can go autodesk.com and create an Autodesk account. So if you have Fusion 360 installed, so you just go here and yes, I'm going to use Jorge. I hope Jorge is going to be my victim. Garcia at Autodesk.com. And I'm going to go ahead and select invite. He's going to get email an invitation in which then he now will have access to this. Now, let's say, for example, I don't want to actually share, or those that want to share with, they don't have Fusion 360. You can click on this little globe here, and it's going to open it up on the web. And this is going to open up something called Fusion Team. In Fusion Team, so it's going to open up this project, this entire project in Fusion Team. So let me just, I need to get off of full screen mode here. Okay. Oh, here it is. Okay. So that opens up Fusion Team, as you see here. This is the entire content of my project, as you see here. My project, I could have subfolders in here as well if I needed to, but you'll notice that the entire content that I have here is the same content that I have on my project over here as well. Okay. And if you wanted to add more members to this project, that way they could see it, you could send this link over to somebody that does not have Fusion. That way they could actually take a look at what's going on. They will, every member that you're going to be adding to this project will actually get an invitation as well. In essence, that's everything I wanted to be able to demonstrate today. The versioning, the electromechanical capabilities, the collaboration tools, everything that you need to get your project done under one platform. From here, remember, and one thing that I wanted, one key point from the PowerPoint I wanted you to make sure that you remember was the fact that we're able to do a lot more than just the PCB design. There's a lot more that you could do. Remember, you could do e-cooling, you could do rendering, you could do you could drive your CNC machine, you could actually create your manufacturing drawing, as well as inserting that PCB into an existing enclosure. That way you make sure it actually fits virtually as well. I would like to thank everybody for joining us today. It's been an honor and a pleasure to do this presentation. I hope the information is of your liking and that you're able to take advantage of it and hopefully make your next smart product using Fusion 360 as your tool of choice. Thank you for joining. My name is Edwin, and always a pleasure to work with Jorge and manning the chat. So that's everything I wanted to cover for today. So, Jorge, is there anything that I should cover or anything I should mention? Looks like you have it under control.
Yeah, for now there's no questions on the chat.
Okay, excellent. Well, if you have any questions or anything else you would like to learn from this, please do a search for Fusion 360 Forum. Our forum is actually extremely active. Jorge is always there and available. And we have a host of team members that are actually part of our different development teams that monitor our forums and are more than willing to answer questions or look into, you're looking into workflow capabilities. They're more than willing to explain there. So make sure that you visit our Fusion 360 forum as often as you can and join the community, the large community that we currently have. And for our Eagle users, please, you could also visit the site in case you have any questions when you're adopting Fusion 360 for your designs. Remember, your libraries are 100% compatible. Your designs are 100% compatible as well. And if you're already using managed libraries, you virtually don't have to do anything because when you do the add command, those managed libraries are going to show up there as well. So you don't have to really do anything different as well. It's been a pleasure for all of you that join us. Greatly appreciate it. And everybody, have a great day. Jorge, thank you so much. I appreciate it.
Bye everyone. Take care.
It's been a pleasure. Bye. Thank you. Thank you,
Bye.
Luis.